Good morning, students. Today we'll talk about the new chapter, that is differentiation for class 12th mathematics. Let's talk about what is differentiation. Okay, so the topic is differentiation. The topic is differentiation. Differentiation means if we try to find the real meaning of differentiation, then we can say that that is rate of change of anything with respect to another element, another variable, that is x. Like for example, if I say, I can say this v is a velocity where x is displacement and t is time. That is, rate of change of displacement with respect to time is called a velocity. Okay, so similarly, if I need to find the acceleration, we can move like this, right, like this. That is the rate of change of velocity with respect to the rate of change of time. So that is what is called the differentiation and is the real meaning of differentiation. Now we'll try to apply them in mathematics. How? Let us see. We have here, that is, we can say we have the formulas which will be applied in the differentiation. That is first principle. Okay, so now first principle, what the first principle says, let's try to find out. That is, f dash x is equal to f of x plus h minus f of x upon h. Okay, that is the formula which says about limit h tends to 0, we have function of f plus h minus fx upon h. Then we have more formulas. We have the chain rule. We have chain rule. First of all, we'll see which formulas are applied, then we'll apply them in the numerical. We have a chain rule, that is u plus v differentiation will be u differentiation plus minus v differentiation. Then we have the product rule we have. Okay, now what the product rule says, that is u into v differentiation, that is u into v differentiation plus v into u differentiation. Okay, like this. Then we have the quotient rule also. We have the quotient rule also. What it says about u upon v differentiation is equal to v into u differentiation minus u into v differentiation upon v square. Okay, so these are the 4 rules of differentiation. Now we'll apply them in the numerical. Okay, so what the formulas, how they will be applied, let us see in exercise questions from the NCERT, that is exercise 5.2. Let's begin with. We have the first question here, and the question says we need to differentiate, that is, they have given sine x square plus 5. So how I'll differentiate? Let us see. Let y is equal to given function. Okay, this is the question says we need to differentiate with respect to x. Question is we need to differentiate with respect to x. Okay, so let's try them. What will be how we'll differentiate this? Now we have assume it as let y is equal to this much. So we'll have dy upon dx is equal to differentiation of sin x will be cos x into differentiation of this will be 2x, because 5 differentiation will be 0, because constant of differentiation you can say will be 0. So we'll write this 2x into cos x square plus 5. Okay, so this is the first question we have done. Let us go for the second one. Now what the second says, we need to differentiate cos sin x. Okay, they have given cos sin x. What we will do? Let y is equal to cos sin x. Okay, so what we'll do? Let us see. Now we'll try to differentiate this. So I got dy upon dx is equal to minus sin x, and differentiation of this will be cos x. Okay, so that is how we easily differentiate the function with respect to the x. Now let us try for the third one. Now we have the third question here, that is sine of ax plus b. So how to do it? A very simple way. Let's first assume that let y is equal to sine ax plus b. Okay, then we move to the dy upon dx is equal to cos of ax plus b, that is differentiation of sin x will be cos x. Then we have differentiation of this, we will find that it will be a only, because so we got a cos ax plus b. Okay, now let's move for the fourth question. We have done 3. Let's try for the fourth. They are saying sec tan root x. We have sec tan root x. Okay, let's assume this as in y. We have that is sec tan root x. Okay, that will do then. Dy upon dx is equal to differentiation of sec x will be sec x tan x. So we'll have sec x and tan x and tan x. Okay, and differentiation of tan x will be sec square x. So we'll have sec square root x. Now differentiation of root x will be half, okay, and upon root x. Okay, so this is the differentiation of sec tan root x. Okay, now we'll try to solve another question. Now we have solved 4. Let's move on to the fifth one now. Now what the fifth question says? Fifth question is sine x plus b upon cos ax plus b. Oh no, cx plus d, sorry, a different angle now. Here is d and here is c. Let y is equal to sine ax plus b upon cos cx plus d. Okay, so this is we have. Now we'll see how we can do it. Here we'll apply this quotient rule. So we'll say dy upon dx is equal to cos cx plus d into differentiation of this will be cos ax plus b into a minus sin ax plus b. Differentiation of this will be minus sin cx plus d into c we have. Okay, upon what will be there? Cos cx plus d. square. Okay, so they have given this. Now if we need to simplify, I got a cos ax plus b cos cx plus d minus, it will plus sin ax plus b sin cx plus d into c. Okay, upon I have cos cx plus d, we have this will be whole square. Okay, so likewise we can easily differentiate the function with respect to x. Okay, now let us move on to the sixth question. What the sixth is? We need to differentiate cos x cube, cos x cube sin square x is power 5. Okay, in a very simple way we can assume that here will be applied as a product rule. Okay, so first consider this. Let y is equal to cos x cube into sin square x5. So dy by dx will have cos x cube. Differentiation of this will be 2 sin x is for 5. Here will be differentiation of sin x will be cos x. So cos x is for 5 and differentiation of this will be 5x4 plus, now leave this, sin square x is for 5 into differentiation of cos x will be minus sin x cube into differentiation of x cube will be 3x square. Now what will be said here is 5x4 cos x cube into cos x raised to 5 into sin x raised to 5 minus sin square x 5. No, we'll take a minus 3x square sin square x 5 into sin x cube. Okay, so that is how we try to differentiate with respect to x. Let us try to solve another question like this. Let us try to differentiate. Okay, so what they have, let us see. In seventh question we have two cot x square root. That is a question we have. Okay, now let's try to do it in a very simple way. Let y is equal to 2 cot x square. Now we'll differentiate it. Now we'll try to differentiate. We'll get 2 into half. Half minus 1 minus half, so it will be here cot x square. And now differentiation of cot x will be minus cosec x into differentiation of x square will be 2x. So I will get this minus 2x cosec x square upon cot x square under root. Okay, so that is how we try to differentiate the function with respect to x. Now let's move ahead. We'll try to solve the question number 8. Okay, so the what question number 8 says, let us see. So we have the question number 8. What the question number 8 says? Cos root x. We have cos root x. So how will differentiate this function? Let us assume that y is equal to cos root x. Now we'll differentiate dy upon dx cos x. Differentiation of cos x will be sin x minus sin x or minus sin x into differentiation of this half x will be root x. So we will get minus 1 upon 2 root x into sine root x. Okay, that is how we try to differentiate such kind of functions. Now let us try to solve another question we have. Ninth. We have solved 8 questions. Now we'll try to solve 9th question. In this, we need to prove the function is given x minus 1 where x belongs to real number. We need to prove that this function is not differentiable at x is equal to 1. Okay. How we'll do it? We'll try to apply here the first principle. How? Let us see first. f1 will be 0. Now we'll apply f dash x is equal to limit h tends to 0 f of x plus h minus f of x upon h. So we'll now apply limit h tends to 0 f of 1 plus h minus f of 1 upon h. Now we'll have limit h tends to 0 1 plus h. We'll write 1 plus h minus 1 minus, if I apply 1 here, 1 minus 1, it will be 0 upon h we have. So we'll have limit h tends to 0 h upon h. It will be limit h tends to 0 h upon h. It will be 1. Okay. Now we'll take the left hand limit. So f dash x will be is equal to limit of x tends to 0 negative we can say. So we'll have 1 minus h minus f of 1 upon h. If I apply it, what I will get? 0 negative I am applying, that is on minus h. Okay. So we'll have limit x tends to 0 minus h is equal to 1 minus h. So we'll have 1 minus h minus 1 minus 1, same condition here, upon h. Okay. Negative I am applying here, so it will be negative h minus h. So now we'll have limit x tends to h negative. So we'll have minus h upon minus h. We'll have limit h negative. So we have here we'll have h tends to 0. So we'll have h upon minus h. It will be minus h. So we can see here in the RHL we have 1, in LHL we have minus 1. So therefore we can say that f dash x, that is what I will write here is x tends to 0 negative is not equal to f dash x of x tends to 0 plus. LHL limit is not equal to RHL limit, so we can say this function is not differentiable at x is equal to 1. Therefore, we can say not differentiable at x is equal to 1. Okay, so that is how we try to find that function is differentiable or not. Now we'll try to solve another question we have. Now let us try to solve the 10th question now. So we have the 10th question. What it says: what the 10th question says, that prove that the greatest integer function, this is the greatest integer function, okay, where x lies between 0 to 3. We need to prove that this greatest integer function is not differentiable at x is equal to 1 and 2. Okay, so we'll apply the first principle here. Okay, limit h tends to 0, we have f of x plus h minus f of x upon h. Now we'll apply h tends to 0, f of 1 plus h minus f of 1 upon h. So we have limit h tends to 0, 1 plus h. So we'll have 1 plus h, we have minus 1. Now we can consider here upon h. Okay, 1 plus h will be, that is more than 1, we can consider as 1. So 1 minus 1 will be 0. So it will be 0 upon h. So it will be 0. Okay, now let us consider the LHL. H tends to 0 negative. So we'll have f of 1 minus h minus f of 1 upon we have h. Okay, so now what we have, limit h tends to 0 negative f of 1 minus h. So 1 minus h, we have, if I put here, that is 1 minus h minus 1 upon h. Now 1 minus h will be less than 1, consider it 0. So 0 minus 1, 0 minus 1, it will be minus 1 upon h. Okay, so if I say this, limit h tends to 0, minus 1 upon 0, so we'll have infinity. Okay, so now we can see that f dash of x, that is h tends to 0 negative, is not equal to f dash of x, that is h tends to 0 plus. So we can say this function is not differentiable at x is equal to 1. Similarly, it is also not differentiable at x is not equal to 2 also. Okay, so this is how we able to find that a function is differentiable at the exact value or not by checking its LHL limit and RHL limit. If both are equal, then the function is differentiable, or if it is not, then we will say that a function is not differentiable. Okay, so that is how we try to find the differentiable of any function.